In a few years' time, the sight of Concordes on international airfields all over the world will be commonplace if all goes well. Then there'll be 130 passengers on board. Flying times will have been cut by half. London to New York from 7 hours 40 minutes to 3 hours 25 minutes.
It is sleek, it is fast, and it was a technological masterpiece. Do you know the Concorde could fly from London to New York in just 3 hours? That is very, very fast. But why did it disappear? So in this video today, I was talking about how the Concorde actually managed to break the sound barrier and whether the supersonic travel is actually making a comeback. So sit tight and let's enjoy this together. So at first, let's understand what the supersonic speed is and how the Concorde actually managed to break the sound barrier. So first, what is supersonic speed? A supersonic speed actually happens when an aircraft actually flies faster than the speed of sound, which is around 1,235 km per hour or 767 miles per hour at sea level. At this speed, the aircraft actually generates something they call shock wave, producing a phenomenon called the sonic boom, something like this. Imagine pushing through a wall of air. The faster you go, the more resistance you face. So that's why we actually need powerful engines and specialized design to actually break the sound barrier. So Concorde wing design was as bold as its engines. Instead of traditional sway points, it used a delta wing, a large triangular shape that gives it the aerodynamic edge needed to fly at supersonic speed. The delta wing provided incredible stability and low drag when cruising at Mach 2. Unlike other commercial planes, Concorde didn't need separate horizontal stabilizers. The entire wing structure helped balance and maneuver the aircraft even at extreme altitude. But the futuristic shape comes with a trade-off. At low speed, the delta wings generate less lift, making takeoffs and landing more challenging. Concorde had to fly faster than supersonic jets during these phases, require longer runways and highly trained pilots. It also lacked traditional flaps or starts, so it couldn't slow down as effectively on approach. To compensate, Concorde used a drop nose to give pilots better visibility during landing and relied on its powerful engines and precise control surface to stay stable throughout descent. Still, the delta wing wasn't just functional, it was iconic. It gave Concorde its sharp bird-like nose and played a crucial role in making sustained supersonic travel not just possible but beautiful. Like normal passenger aircraft, the Concorde delta wings actually produce lift and stability at high speed, but it also makes landing and taking off more challenging. One of Concorde's most iconic and challenging features was its propulsion system. It was powered by 4 Rolls-Royce Sikima Olympus 593 turbojet engines, originally designed for military bombers like the Avro Vulcan. These engines were just built for comfort or efficiency. They were built for power, and power is exactly what Concorde needs to cruise at Mach 2, over twice the speed of sound. Each engine produced a massive 38,050 pounds of thrust, giving the Concorde a combined total of over 152,000 pounds of thrust, more than enough to punch through the sound barrier and sustain supersonic flight for hours. To achieve this speed, the engines relies on afterburners or reheaters, which injected extra fuel into the exhaust to produce an enormous boost in thrust. This gave Concorde the fiery thunderous takeoff, and it became its signature. The afterburners were used during takeoff and acceleration through the sound barrier, but they burned fuel at an incredible rate and created a deafening roar. In fact, Concorde was so loud that it was banned from flying over land in many countries, limiting its transatlantic routes. But the innovation didn't stop there. The engines were paired with variable intake wrap system, which slow incoming air from supersonic to subsonic speed before it enters the engines. Without this, the airflow could destroy the turbine plates. This system automatically adjusted during flight, an impressive example of engineering finesse in an already cutting-edge aircraft. Though powerful, the engines were thirsty, noisy, and not environmentally friendly, but they were a symbol of bold, uncompromising ambition, designed not just to fly but to break the rule of what commercial air travel could be. These engines were incredibly powerful, but they also fuel hungry. They take a lot of fuel. So that's why the Concorde is actually expensive to operate. At Mach 2, friction with air caused the Concorde aluminum skin to heat up to 127 degrees Celsius, which is 261 degrees Fahrenheit. This aircraft would even expand nearly 30 centimeters, which is 12 inches, during flight. Imagine hearing an explosive every time an airplane actually flies by, like the sonic boom, that is very loud, like a boom, boom, something like that. You'll be more frightened in your house, you're like, what is happening? Who is throwing some bombs, So, the Concorde could burn up to 25,600 liters, which is equivalent to 6,800 gallons of fuel per hour, making it far less fuel efficient than supersonic jets. Despite its brilliance, the Concorde faced three major issues. The 2000 Air France crash, rising fuel cost, and declining passenger demand. This factor led to his retirement in 2003. The future of supersonic travel. Companies like Boom Supersonic and NASA are developing the next generation of supersonic jets, which is quite faster and more fuel efficient. The Concorde is an engineering marvel, and maybe one day the supersonic travel will actually make a comeback. So, what do you think? Let me know that in the comment section. So, here why the Concorde actually flies and why it fails. So let me know what you think down in the comment section. So thank you for watching this video to the end. If you do watch to the end, please like and subscribe, please.